Hello audience. Greetings of the day. Today we will discuss about the electrostatic discharge, well known as ESD. Whenever an electrically charged object discharges, it produces an ESD, an electrostatic discharge, event. An ESD event can subject an electronic device to thousands of volts and several amperes. High voltage can cause breakdown in a device structure and high current can cause heat that damages the device. The current discharged into a device depends on the ESD voltage and on the characteristics of the device's current path. But, the amount of current that passes through a device can be drastically different for a given discharge voltage, depending on the test method. Unfortunately, the differences in current for a given voltage are not always well understood. HBM, Human Body Model, AM, Machine Model, and CDM, Charged Device Model. CDM produces a much shorter current pulse than either HBM or AM, but it produced a substantially higher peak current. HBM and AM can deliver more energy to the device under test, but high peak currents are often the best predictor of damage. Using waveform plots on different time scales, we compares the current waveforms produced by tests that comply with two ESD system level test standards, IEC 61004-2 and ISO 10605, which use different resistor and capacitor values in their test circuits. ISO and IEC HBM ESD tests are important for ensuring high electronic quality. The test limits for the ESD charging voltages increased within the last years up to 25 kV and more. At the same time, shrinking dimensions and higher package density lead to more endangered electronic devices. The demand for more functionality in automobile electronics causes a rising number of electronic components. These components are connected via the car cable harness. Hence, the damage potential by ESD events increases. ISO 10605 is partly based on IEC 61004-2, a standard that covers system-level ESD immunity. However, it has several key differences specific to automotive applications. Unlike IEC 61004-2, ISO 10605 does not define specific upper limit of stress voltage. However, the test voltages are generally in the range of 2 kV to 15 kV for direct contact discharge, and 15 kV to 25 kV for air gap. However, some automotive manufacturers have their own specifications, and some parts can have specifications as high as 30 kV contact, 30 kV air gap discharge. The generator is set to meet the parameters shown in figure. ISO 10605 testing uses two different resistors, 2 kΩ and 330 ohms, to simulate different types of ESD events. The 2 kΩ resistor represents a human body discharging directly through the skin, while the 330 resistor simulates a human body discharging through a metallic object. The test is also done at two different capacitances, 150 picofarad and 330 picofarad. These values represent a human body inside and outside the vehicle respectively. The 330 picofarad and 330 test is the highest energy current of any of the ISO 10605 test parameters, and thus is the most widely used test standard. Figure shown is an example of the ISO 10605 discharge equivalent circuit. The circuit starts off with the switch open, and charges the 150 picofarad, 330 picofarad capacitor. Then the discharge is represented by the closing of the switch, which causes the capacitor to discharge across the dot. The resistor represents the resistance of the gun, and the inductor and capacitor represent the LC parasitics. The figure summarizes the similarities and differences between ISO 10605 and IEC 61004-2 test parameters. The 150 picofarad and 330 test is roughly equivalent to the IEC 61004-2 test. Figure shows the different waveforms at their respective capacitance and resistance levels. Shown waveforms of 5 kV contact discharges, and help illustrate the variation in energy dissipation related to the resistance and capacitance values. Figure shows the waveforms of 5 kV contact discharges under ideal conditions. The noise seen in figures could be attributed to a variety of factors, such as LC parasitics or noise from the generator or discharge gun. As illustrated in figures, the 330 picofarad discharge, simulating a body outside the vehicle, has more energy than the 150 picofarad discharge, simulating a body inside the vehicle. This is because the higher capacitance dissipates over a longer period of time. The 330 discharge also dissipates more energy than the 2 kilo discharge due to its lower resistance. Because of this, the 330 and 330 PF discharge has the highest energy of any of the tests, which is shown by having the largest area under its curve below. Since IEC 61004-2 has a lower capacitance of 150 pF and 330, ISO 10605 at 330 pF and 330 has a longer period of energy dissipation. Because of this, the stress on the device and change in temperature in ISO 10605 is significantly higher than IEC 61004-2, making it a more intensive test. ESD test bench setup complies with the ISO 10605 standards as shown in figure. The device under test, DUT, is placed on a horizontal coupling plane, HCP. Two 470K resistors in series connect the HCP to the ground reference plane, GRP, and all devices are placed on a non-conductive table. Unlike IEC 61004-2, ISO 10605 is supposed to simulate the discharge of a device into a vehicle, so the generator, referred to as ESD simulator in the image, is grounded to the table, upper HCP, instead of the earth. That is because the table is supposed to act as an independent body isolated from the earth. The illustration in figure gives a basic overview of the rest of the setup. Note the grounding of the simulator to the table, HCP, instead of the floor. So we conclude that testing and verifying transient immunity is a vital component in ensuring the reliability of modern electronic components, and ISO 10605 provides the guidelines for automotive ESD testing. While ISO 10605 standard is similar to the IEC 61004-2 standard, it has several key differences. 1. The generator is grounded to the table instead of the floor to simulate the isolated environment of a vehicle. 2. The test is performed at different resistance values to simulate the discharge of a body directly and through a metal object. It is also performed at different capacitances to simulate a discharge both inside and outside the vehicle. While there are a variety of other differences, ISO 10605 is quite similar to IEC 61004-2, and it is the industry standard for ESD protection devices in automotive applications. We Crawdon Services Private Limited provide you the electrostatic discharge testing services as per ISO 10605 and IEC 61004-2 as per your requirements. Thank you.